The microbiome field has been hot for at least 15 years now, maybe a little more, maybe about, closer to 20 maybe. But it started off with a technology called 16S technology, which is actually looking at one specific region of one gene of the bacterial kingdom. And so it's a very narrow view of what is going on in the gut microbiome. So it's sort of like saying, like let's say in the US, right? You look at, people's height and decide what their health is or something like that. That's kind of the analogy that comes to my mind when I think about 16S. You can be very wrong. And occasionally you may be right. But the amount of information you have with 16S technology, which is the first technology that started off the microbiome field, is so small. And there's now lots of articles that have basically said the number of false positives and false negatives, basically the false discovery rate of 16S technology is something like, 55% or something, or 60%, something like that, some very large number. So it's super unreliable, super unreliable. People have recognized this now for the last few years. Let's say about 4 or 5 years, people have recognized this. But unfortunately, you know what? Most of the scientific community who has done clinical studies have all focused on the 16S technology because it's cheap, it's widely available, and people in the academic industry, so to speak, they sort of say, hey, let's take the path of least resistance. They have very little money to spend on grants and so forth. They just do studies. So I would say 98, 99% of the papers you see today in the microbiome field are coming from 16S technology, which is super unreliable. I will bet you that those 7 companies that the paper talks about, probably 5 or 6 of them are based on 16S technology. So that tells you why it's so unreliable. So that's first generation microbiome technology. Then there was a second generation microbiome technology, which is called metagenomics. So instead of looking at just one region of one gene, now they look at all the genes in the microbial genome. Like in a bacteria, you have 3,000 genomes, a typical bacteria. So they look at all 3,000 genes in the genome. And the problem with that second generation metagenomic technology is that they only look at the DNA of the genome, right? Which basically means these are all the possible things that can happen when the genes of a bacteria gets expressed. So it's the potential, it's not the actual. Turns out I can show you the data if you're interested, but less than 5% of the genome of a bacteria is expressed at any given point in time. Less than 5%. So which 5% of the 3,000 genes is expressed kind of determines what's actually going on in the bacteria. Is it just doing something completely neutral? Is it doing something beneficial? It's doing something harmful? All of those things are possible because those are all genes that are encoded in the genome of the bacteria. But metagenomics simply says this taxa, like this organism, meaning a particular genome exists. We don't know what it's doing. Is it good? Is it bad? It's neither. We don't know what's going on. That's second generation. And I would say maybe there's like 1 or 2% of the whole academic work, meaning papers. And there's probably a few companies, maybe 2 or 3 companies that are doing metagenomics right now. So there's very little work even in metagenomics. And then the technology that Viome uses is called metatranscriptomics, which is the third generation, is how I think about it. And in this third generation technology, you're looking at exactly what is going on in the expression of the genes that any bacteria is literally emitting in terms of its biochemistry, right? So it's like, some bacteria, like you can take, classic bacteria like Akkermansia. People talk about Akkermansia in the gut health space. People talk about Akkermansia quite a lot. Akkermansia mucinifera, right? Akkermansia mucinifera, when it's expressing one portion of its genome, it's actually super beneficial. It's used as a probiotic for metabolic disease. There are companies that are formed by, just using Akkermansia as a probiotic, right? But on the other hand, it's been shown that there are other parts of the genome when it's expressed, it can lead to Parkinson's disease. So there's a wide range of behaviors possible, even within a standard microbe or a bacteria like Akkermansia. So the way that metatranscriptomics approaches the whole world of microbiome is by looking at which genes are expressed. So that's the third generation of microbiome technology that is going to really make a difference. Unfortunately, the field of microbiome is, moving pretty fast, and I don't think most people are kind of up to speed with this evolution of these three generations of the technology. But I'm happy to be able to, give a little intro to that.